Another day, another story. Einstein's theory of relativity paved the way for black holes' discovery, but the concept behind their existence was so bizarre that even the scientific visionary was not convinced. Indeed, black holes are one of the most intriguing and extreme concepts in the field of theoretical physics. Welcome to Tabo Eminent Channel. The idea of black holes, as we understand them today, emerged from Albert Einstein's general theory of relativity, which he formulated in 1915. However, even Einstein himself had reservations about the existence of such objects. When Einstein first developed his general theory of relativity, he realized that the equations allowed for the possibility of massive objects causing a curvature in spacetime significant enough to prevent anything, including light, from escaping its gravitational pull. However, Einstein was uncomfortable with this idea and questioned its physical relevance. He thought it was a mathematical curiosity rather than a physical reality. In 1939, Einstein published a paper with physicist Nathan Rosen in an attempt to disprove the idea of black holes, suggesting the existence of wormholes as an alternative explanation for the peculiar behavior predicted by general relativity. It took several decades, advances in both theoretical understanding and observational evidence, for the concept of black holes to gain acceptance within the scientific community. In the 1960s, physicists like Roger Penrose and John Wheeler made significant contributions to the theoretical understanding of black holes, and in the following years, astronomical observations provided compelling evidence for the existence of these mysterious objects. Today, black holes are a well-established concept in physics and astronomy, supported by a wealth of observational data, including the recent imaging of the supermassive black hole at the center of the galaxy M87 by the Event Horizon Telescope in 2019. Despite Einstein's initial doubts, black holes have become a fundamental aspect of our understanding of the universe. More than a century ago, Albert Einstein stunned the world when he explained the universe through his theory of general relativity. The theory not only described the relationship between space, time, gravity, and matter, it opened the door to the theoretical possibility of a particularly mind-boggling phenomenon that would eventually be called black holes. The concept that explains black holes was so radical, in fact, that Einstein, himself, had strong misgivings. He concluded in a 1939 paper in the Annals of Mathematics that the idea was not convincing and the phenomena did not exist in the real world. The unveiling of the first-ever picture of a black hole by the Event Horizon Telescope in April 2019, however, not only confirmed Einstein's original theory, but also provided indisputable proof that the gravitational monsters are, in fact, real. The SpaceTime Theory. As described by American physicist John A. Wheeler, general relativity governs the nature of spacetime, particularly how it reacts in the presence of matter. Matter tells spacetime how to curve, and spacetime tells matter how to move. Picture a flat rubber sheet, spacetime, suspended above the ground. Place a bowling ball in the middle of the sheet, matter, and the sheet will distort around the mass, bending halfway to the floor. This is matter telling spacetime how to curve. Now roll a marble, matter, around the rubber sheet, spacetime, and the marble's trajectory will change, being deflected by the warped sheet. This is spacetime telling matter how to move. Matter and spacetime are inextricably linked, with gravity mediating their interaction. Now, place a singularity, a theoretical point of infinite density, onto the sheet. What would happen to spacetime? It was German theoretical physicist Karl Schwarzschild, not Einstein, who used general relativity to describe this hypothetical situation, a situation that would become the most extreme test of general relativity. At a certain threshold, Schwarzschild found that the hypothetical singularity would literally punch through spacetime. In mathematics, singularities are interesting numerical solutions, but astrophysical singularities were, at the time, thought to be an abomination. There was no known mechanism that could produce them. Schwarzschild, however, persisted until his death in 1916, realizing that an astrophysical singularity would warp spacetime so severely that even light would not be fast enough to get out of the spacetime hole that the singularity would create. The point of no return, a spherical region surrounding the singularity, would become known as the event horizon. Known physics breaks down beyond the event horizon and, as no information can escape, we can have no experience as to what lies inside. Though this was an interesting concept, there was no known mechanism that could create a singularity in nature, so the idea was largely overlooked. Concept of black holes are born. That was until 1935, when Indian astrophysicist Subramanian Chandrasekhar realized that, should a massive star run out of fuel, the sheer gravitational pressure of that mass would be concentrated to a point, causing spacetime to collapse in on itself. Chandrasekhar had bridged the gap between mathematical curiosity and a scientific possibility, seeding the theory behind the formation of a real singularity with extreme consequences for the fabric of spacetime. Even with Chandrasekhar's contributions toward the modern understanding of the nature of black holes, astrophysical singularities were assumed to be, at best, extremely rare. It stayed that way until the 1960s when British theoretical physicists Stephen Hawking and Roger Penrose proved that, far from being rare, singularities were a part of the cosmic ecosystem, and are a part of the natural evolution of massive stars after they run out of fuel and die. And it wasn't until 1967, 12 years after Einstein's death in 1955, that these astrophysical singularities became known as black holes, a term coined by American physicist John A. Wheeler during a conference in New York to describe the grim fate of a massive star after it runs out of fuel and collapses in on itself. The black hole teaches us that space can be crumpled like a piece of paper into an infinitesimal dot, that time can be extinguished like a blown-out flame, and that the laws of physics that we regard as sacred, as immutable, are anything but, Wheeler wrote in his 1999 autobiography. Thanks to astronomers and computer scientists working with the Event Horizon Telescope, EHT, a network of 8 linked telescopes, humanity was finally able to visualize these infinitesimal dots. Although Einstein wasn't alive to see evidence of black holes, the result of real singularities about which he remained doubtful, his theory of relativity made their discovery possible. Einstein's Enigma. In the quiet study of Princeton University, where the rustle of papers and the scratching of pens filled the air, Professor Albert Einstein stared at the complex equations sprawled across his chalkboard. The equations hinted at a phenomenon so extreme, it challenged the very fabric of space and time: black holes. Einstein's brow furrowed in deep contemplation. The year was 1935. Einstein's colleagues, including a brilliant young physicist named Amelia Hartwell, had embraced the radical idea of black holes. However, Einstein, the genius who had reshaped our understanding of the universe with his theory of relativity, found himself skeptical. Could such bizarre entities truly exist? Amelia, a determined scientist with an insatiable curiosity, sensed Einstein's uncertainty. She approached him one evening, her eyes sparkling with enthusiasm. "Professor Einstein," she began, "I believe black holes are not mere mathematical oddities. They are cosmic phenomena waiting to be discovered." Einstein gazed at her, his piercing eyes softening. "My dear Amelia, the concept is intriguing, but I am not convinced. How can something so extreme be real?" Undeterred, Amelia embarked on a quest to prove the existence of black holes. Armed with newfound knowledge and an unyielding spirit, she delved into the mysteries of the universe. Years passed, and technological advancements in telescopes and detectors brought humanity closer to the cosmos. In 1964, Amelia made a groundbreaking discovery. Through meticulous observations of distant galaxies, she found compelling evidence: stars orbiting an invisible, massive object. She had discovered the telltale signs of a black hole. Excitedly, she rushed to Princeton to share her findings with Einstein. As Einstein listened to Amelia's explanation, his eyes widened with realization. The skepticism that had clouded his mind for years began to fade. "Remarkable," he whispered, his voice filled with awe. Together, they collaborated on refining the theory of black holes. Amelia's discovery had bridged the gap between theoretical mathematics and empirical evidence. Einstein, now convinced of their existence, marveled at the wonders of the universe he had once doubted. The scientific community celebrated their work, and the enigma that had perplexed Einstein was now a cornerstone of astrophysics. Amelia's name joined the pantheon of great scientists, her determination forever etched in the annals of history. In the years that followed, humanity continued to explore the cosmos, guided by the knowledge unlocked by Amelia's discovery. And as telescopes pierced the veil of space, revealing the secrets of distant galaxies and the enigmatic hearts of black holes, they stood as a testament to the relentless pursuit of knowledge, a legacy that began with Einstein's skepticism and was realized by Amelia's unwavering belief in the mysteries of the universe. Beyond the event horizon. In the not-so-distant future, Humanity had mastered the art of space travel, venturing into the far reaches of the cosmos. Dr. Maya Carter, a brilliant astrophysicist, had spent her life fascinated by black holes. She had a radical theory: beyond the event horizon, where all known laws of physics seemed to collapse, there existed not a chaotic oblivion, but an uncharted universe waiting to be explored. Maya's theory challenged conventional wisdom, drawing skepticism from the scientific community. Undeterred, she built the Event Horizon Explorer, EHE, a cutting-edge spacecraft designed to withstand the immense gravitational forces near a black hole. With a team of dedicated scientists, she embarked on a daring mission to prove her theory. As the EHE approached the event horizon of a distant supermassive black hole, Maya and her crew marveled at the cosmic spectacle before them. The black hole, surrounded by a shimmering accretion disk, seemed to defy the laws of nature. Heartbeats quickened as they crossed the threshold, venturing into the unknown. To their astonishment, they found themselves in a surreal realm, a universe within the black hole. There, fundamental constants of nature behaved differently, giving rise to breathtaking phenomena. Stars the size of planets glowed in hues unseen in the observable universe. Time and space intertwined, creating mesmerizing displays of temporal ripples. Amidst the wonders, they encountered an ancient, advanced civilization, the Enthralans. These beings had learned to harness the unique properties of their black hole home, transcending the limitations of mortal existence. Maya, humbled by their wisdom, shared her knowledge of Earth and the cosmos. The Enthralans revealed a startling truth: their ancestors were humans who had ventured into a black hole millennia ago. These intrepid explorers had become beings of energy, exploring the universe in ways unimaginable to humans of the present era. Embracing this newfound knowledge, Maya and her crew decided to stay with the Enthralans, becoming custodians of the cosmic gateway between the two universes. From their new home within the black hole, they observed the universe outside, guiding future generations of explorers to the wonders that lay beyond the event horizon. And so, in the heart of a black hole, humanity found not an end, but a beginning, a gateway to a universe of endless possibilities, forever altering the course of human understanding and exploration. And, no doubt he also would have marveled at the ghostly crescent surrounding a near-perfect dark disk, proof that even the most outrageous theories can turn out to be true. Thanks for watching. Request you to subscribe the channel.